Hello everyone and welcome to another episode on this video channel. So in today's lesson we shall be looking at the angle properties of power lines. Angle properties of power lines. If you haven't yet subscribed to my channel, kindly hit on the subscribe button for me. So let's set the ball rolling. When we talk about power lines, they are lines that do not meet no matter how far they travel. They are lines that do not meet no matter how far they do what? Travel together. So this is an example of two power lines. They are all heading towards the direction. No matter how far these two lines travel, they will never meet. When these two power lines are being intersected by a transversal line, we can obtain the angle properties of power lines. So let's draw our slanted line. So this slanted line is called the transversal line. It's called what? The transversal line. And then these two lines are called what? The power lines. They are called the power line. So when we have something of this well form, we can have the angle properties of power line being formed on this power line and then the transversal line. So we are going to go through each one of them one after the other. So we are starting with what we call the intersection of lines. The intersection of lines. So with the intersection of lines, what we are saying is that when you have two lines being intersected, then we can obtain what we call the vertically opposite angle. So this is, let's say this is our line 1 and this is our line 2. Now when these two straight lines intersect, we can obtain what we call the vertically opposite angle, also known as what? The opposite angles. So this means that the angle formed here is equal to the angle formed here. So we have this, so we can see that this angle is vertically opposite to this angle. So if this angle is, let's say, 40 degrees, definitely this angle will also be what? 40 degrees. And we call it the opposite angle or the vertically opposite angle. Also, the angle formed here, we can also say that the angle formed here is opposite to the angle formed here. So if this angle is, let's say, 140 degrees, then definitely this angle will also be what? 140 degrees. And this is what we call the opposite angle. We call it what? The opposite angle or the vertically opposite angle. So let's look at example. So we want to find the value of angle x and then angle y in this diagram. So we can see that we have two straight lines. So let's say line 1 and then line 2. They are all intersecting at these raw points. So we can have the opposite angle being formed. So you can say that the angle formed here is vertically opposite to the angle formed here. Therefore, we can say that angle x is equal to what? 60 degrees. Very, very easy. You just have to look and then you see. Then what about angle y? You can see that angle y is opposite to angle 120 degrees, and therefore we can say that angle y is also 120 degrees. Very, very easy and then simple. Let's look at the other angle properties of power lines. So with the others, we shall be looking at what we call the corresponding angles, the co-interior angles, and then the alternate angles under the angle properties of power lines. So let's start with the corresponding angle. So when you have two power lines being intersected by a transversal line, as we said, this is our transversal line, then we can obtain what we call the corresponding angle. So these are the corresponding angles are being formed. So this is our transversal line. On the left hand side of the transversal line, I mean this side of the transversal line, the angle on top here correspond to the angle on top of the second power line. So we call these two angles corresponding angle. If that is the case, if this angle is, let's say, 20 degrees, then definitely this angle will also be what? 20 degrees. We call them corresponding angle. Now the angle beneath here also correspond to the angle beneath here. So if this angle is, let's say, 160 degrees, then definitely this angle will also be what? 160 degrees. We call them corresponding angle. Now on the right hand side of the transversal line, this is the transversal line. On this right hand side, the angle on top of the first power line, this angle correspond to the angle formed on top of the second power line. So you can see that this angle is equal to this angle. So if this angle is, let's say, 100 degrees, then this angle also be what? 100 degrees. Then beneath the first power lines too, the angle formed here is also equal to the angle formed here. So you can see that this angle corresponds to this angle. So if this angle is 80 degrees, this angle will also be what? 80 degrees. We call it the corresponding angle. It's very, very easy and then simple. So let's take it that let's use letters to represent them. So we say that if this angle is A, then this angle will also be A. If this angle is B, then this angle will also be B. If this angle is C, this angle will also be C. If this angle is D, this angle will also be what? D. We call them the corresponding angle. Now let's look at the co-interior angle. The co-interior angle. The co-interior angle, we are looking at in between these two power lines. In between what? These two power lines. So with the co-interior angles, they are supplementary. Co-interior angles are what? Supplementary. That is, they sum up to 180 degrees. That is what? They sum up to 80 degrees. So these two angles here are called the co-interior angles. They are called the co-interior angles. When we add these two angles together, it will give us what? 180 degrees. So we can say that angle D plus this angle C should give us what? 180 degrees. That is why we are saying that co-interior angles are supplementary. Supplementary means that they sum up to 180. Now when we move on to the left hand side of the transversal line, we have two angles in between the two power lines. And when we add these two, we should get what? 180. So angle A and angle B. So we have angle A plus angle B should give us what? 180 degrees, because they are also what? Co-interior angles. So co-interior angles are the angles formed between the two power lines. And when we add them, it should give us what? 180 degrees. Very, very easy and then simple. Now the next one is for the alternate angle. The alternate angle. Now with the alternate angle concept, it takes the shape of Z, and then what? A slanted F. A slanted what? F. So we can decide to clean this to make it like this. So with the alternate, what it says is that the angle formed here is equal to the angle formed here. So if this angle is, let's say, 40 degrees, then this angle will also be what? 40 degrees. We call them the alternate angle. So when you see any shape of this form, then you can apply the alternate angle concept. Now with the F, the slanted F, we can also say that the angle formed here is equal to the angle formed here. So we call this the alternate angle concept. Now from the diagram here, we can have the alternate angle concept formed. So you can see that the angle formed, the angle here, we can see some Z shape. We have this one and this. Can you see that? So it means that the angle here is equal to the angle here. So you can say that angle B is equal to what? Angle C. That is the alternate. It looks like what? A Z. I believe you can see it. You can see the Z shape. So that is the Z shape formed from the alternate angle. So this angle is equal to what? This angle. That is the alternate angle concept. We can also have the slanted F from the same diagram. We can see that the shape here, the F shape here. So you can see that this angle is also equal to this angle. Very, very easy and then simple. So these are the angle properties of power lines, the corresponding angles formed here, the co-interior angles, the angle between the two power lines, and then the alternate angles that takes the shape of Z, and then the slanted F. We are going to take like 2 examples and then away back. So we want to find the angles marked with letters in the diagram below. So you can see that we have two power lines being intersected by a transversal line. If you see that, then it means that you can make use of what? The angle properties of power lines, the corresponding, the co-interior, the alternate angle concept. You can also make use of what? The vertically opposite angle concept. So we want to find angle X and then all of this. So looking at this diagram, we only have this angle being given. So we are going to base on this angle to find all the given angles. So the first one that we are going to look at is, you can see that this angle 118 is what? Opposite to this angle. Can you see it? So wherever is this one, we don't work so many, just have to apply the angle properties. So we can say that this is our solution. Angle Y is equal to what? 180 degrees. And we are using what? The opposite angle concept. Very, very simple and then easy. Now from the same 118, it means that this angle is 118. Angle Y is 118. Now from the same angle 118, you can see that angle 118 correspond to angle what? W. So you can say that angle W is also equal to what? 118. We are using what? The corresponding angle concept. Now from the same angle W, we can apply the alternate angle concept. You can see that we have some F shape here. F, a slanted F. So it means that angle Y is equal to what? Angle W. So angle Y is equal to angle W. And that is what? Angle Y is 118. So 118 is equal to angle W. And we are still going to get the same angle as that. So angle W is 118. Angle W is 118. So when you use the alternate angle concept or use the corresponding, you are still going to get the same thing. Now let's continue. Now we know angle W as well. Angle W is also 118. Good. Now angle X, we can apply the co-interior angle. We say that the angles in between the two power lines sum up to 180. So this means that when we add angle Y to angle X, it should give us what? 180. That is what? The co-interior angle. So you can say that okay, let's start with X. So angle Y plus angle X should give us what? 180. Angle Y we had 118 plus angle X, and that is equal to 180. So we have our angle X is equal to 180 minus what? 118. So we have our angle X is equal to what? 62 degrees. So angle X is 62 degrees. 62 degrees. Very, very easy and then simple. Now so we are left with what? Angle V and then W. Angle V and then W. Angle V and then W. So with angle V, you can see that angle W is opposite to angle V. Can you see it? So we have this angle is directly opposite to this angle. So you can see that angle V is equal to what? Angle W. Angle W. And we are using the opposite angle. Angle V, we don't know. That is what we have to look for. Angle W, we have 118 degrees. Therefore, angle V is also what? 118. Very, very simple and then easy. And then angle Z. Angle Z is also opposite to angle what? X. It is also opposite to angle X. So it means that angle X is also equal to angle Z. Now with angle X, we have what? 62. Therefore, angle Z will also be what? 62. So we have angle Z. Therefore, angle Z is what? 62. Very, very easy and then simple. This brings us to the end of today's lesson. But I'm going to give you one try question. You pause the video, you try a hand on them, okay? So this is your try question. Find angle A, B, C, D, E, F, G. See you tomorrow. Bye bye.